What is power factor? To understand this, we first need to understand two values, average power and apparent power. Average or real power is the total sum of instantaneous power delivered to resistive loads within a sinusoidal AC circuit. This value is measured in watts and can be calculated for a circuit element by taking the product of the current and voltage through a resistive element of the circuit. However, AC circuits generally require higher voltage and current inputs than what is required for circuit loads due to the draw of capacitors and inductors, the reactive elements of a circuit. These elements use no power, but reduce the circuit's current and voltage, meaning the product of the voltage and current across the terminals of a circuit are not always equal to the power being used by the circuit. This product is known as apparent or reactive power. The ratio between the average power and the total apparent power is called power factor. Denoted FP, it is a unitless value between 0 and 1 that can be determined by dividing the average power by the product of the voltage and current. For example, in an ideal series AC circuit with one resistor and one capacitor, with a power of 2 watts, an applied voltage of 10 volts, a current of 0.5 amps, the power factor works out to be 0.4. If we were to take the resistor out of the circuit, there would be no resistive elements to have power applied to them, so P would equal 0, and the power factor would also equal 0. Thus it follows that any AC circuit without resistive elements will always have a power factor of 0. If instead the capacitor is removed, P will equal VI, and so the power factor will equal 1. Any AC circuit with no reactive elements will always have a power factor of 1. Power factor can also be determined using the phases of the circuit's voltage and current. These measures will only ever be out of phase when reactive elements are present in the circuit. A capacitor shifts the current 90 degrees ahead of the voltage, while an inductor shifts current 90 degrees behind. Thus, it follows that the power factor can be determined by taking the cosine of the phase difference between voltage and current. When phase of the current is ahead of the voltage, as in a capacitive circuit, the power factor is said to be leading. However, if the current is behind the voltage, as in an inductive circuit, the power factor is said to be lagging. For example, if a circuit has a voltage with phase of minus 40 degrees and a current with phase of 30 degrees, the difference in phase is 70 degrees, and so the power factor is 0.63. As voltage is ahead of the current, the power factor is lagging, and the circuit, therefore, is inductor dominant. Thanks for watching.